DevJuniors? What's up? Whether you're falling face first in Fall Guys or building lightning fast in Fortnite, all that in-game physics relies on one thing: instant, perfect collision detection. But how do games figure out millions of times a second if two objects are touching? Today, we are pulling back the curtain on the geometric secret that makes it all possible. The Separating Axis Theorem, or Get ready to level up your game dev knowledge. Let's start with the big problem. Checking for a collision between two simple circles is easy, right? You just compare the distance between their centers to the sum of their radii. But what about two complex, rotated polygons, or even crazier, to 3D objects tumbling through space? The naive approach of checking every single vertex of one shape against every single edge of the other shape, well, it's a computational nightmare. It's way too slow and complicated for a fast-paced game. We need a faster, more elegant rule to know if two shapes are intersecting. And that's where the beauty of the Separating Axis Theorem comes in. The core idea is brilliantly simple. SAT states this: two convex shapes are not colliding if you can find just one single straight line, which we call a separating axis, where their shadows or projections do not overlap. Think of it like this: if you can shine a flashlight from a certain angle and see a gap of clear space on the wall between the two objects' shadows, then they can't possibly be touching. It's all about finding that one critical gap. If a gap exists, there's absolutely no collision. It's an all-or-nothing proof. So, how do we find this magical separating axis? Do we have to test every single possible line in the universe? Of course not. That would be even slower. SET massively simplifies the search. For 2D polygons, we only need to test a specific, finite set of axes. Which ones? The lines that are perpendicular to each edge of both shapes. We call these the edge normals. These normals are our only candidates for a separating axis. So, for a fight between a hexagon and a triangle, we'd only need to check the 6 normals from the hexagon's edges and the 3 normals from the triangle's edges. That's just 9 axes to test. Way more manageable. Okay, so we have our axes to test. What's next? This is the projection step. For each axis we're testing, we take every single vertex of both shapes and flatten it onto that line. Imagine drawing a perpendicular line from each corner of the shape, straight down to our test axis. The points where they land form a simple one-dimensional segment, or an interval, on that line. We do this for both shapes. So, a complex 2D collision problem has now been simplified into comparing two simple number lines. Are they overlapping? Or is there a gap between them? And that brings us to the final conclusion. We loop through each of our candidate axes. On the first axis, we project the shapes and check their intervals. Do they overlap? Yes. Okay, we move to the next axis. We repeat the process. Project and check for overlap. Then we can say with 100% certainty that the two shapes are colliding. What algorithm or game dev secret should we break down next? Let me know in the comments. Thanks for watching. Don't forget to like and subscribe to DevJunior for more deep dives. See